So it's, yeah, as you said, it's a bit technical. It's also a kind of niche topic, but I thought it would be interesting to go back to the basics. So I wanted to share a new pattern that has appeared in the, I would say the world of Golang, which is for something quite fundamental, which is how to handle nullable or optional values, which has always been quite an interesting debate in Golang. And so to introduce this topic, I thought it would be interesting to go back to how Golang works, and so how to say, how Golang, what is Golang's memory model? And to do that, we have to look a bit of at the pointers and how everything works. So that's what I'm going to do. So first, I'd like to introduce by a question. What is an object in Golang? So I will use the word object, but some purists could say it's actually a struct, which is true, but it doesn't really matter. So what happens when you have a struct or an object with some properties? Let's say we have an ID, which is an int on 32 bits, a name, a stock, which is a 64 bits, a price, and some Boolean. And we create an instance of a product, which here we have a banana, which we have 42 bananas for this price. What happens in the memory? So first, each property has, of course, its size. So everything is statically typed in Golang, and it's decided at the compilation time. So for example, our ID is 4 bytes, as we defined. The stock is 8 bytes, the price is 8 bytes. Boolean is always 1 byte. So this string is a bit specific because we have the size and a pointer. So I don't want to go too much in the details of what a string is in Golang. That's not the topic for today's presentation, but it's actually 16 bytes. And so in memory, what this object is, actually it's one contiguous area of memory. We have one chunk of 37 bytes of memory, and that is the memory model of Go. Every object, every struct is one contiguous area of memory, which is statically defined at the compilation time. It's not like in many dynamic languages, like, I don't know, JavaScript or Ruby or Python, like where an object is actually a dictionary or a map. Yeah, in Golang, it's one area of memory and everything is statically defined. So here we have our ID, which is 4 bytes, then the name, which is 16 bytes, the stock, price, and or is deleted flag, which is 1 byte. Yes, so a bit of disclaimer. So I'm going to speak about Go from a higher level perspective. So what's the result when I write the code, which the interpretation can be a bit different if we go down to the lower level. But I want to stay at quite a high level. That's why I'm not going too much in detail about the compiler optimization, for example, or how does the slices, arrays, and strings works, because it would be too long and be maybe too much technical. So first, Golang passes everything by value, which is quite different from many languages. So for example, let's say I have this struct, which is a product with a name and stock, and I want a simple function which takes a product and increases the stock. And then I have my product and I actually increase the stock. So what happens there is that first I create my product. So I get one area in memory. So this is my product in memory. It has this property, which is the name, which is banana, the stock, which is 42. And when I increase the stock, when I call this function, actually this function will not receive this product because Golang will create a copy of my product and then pass it to this function. So here, when I modify the stock, I modify the stock in this copy and not in this one. So actually, this function doesn't have any side effects outside of it itself. And if I want to pass things by reference, I would say, to compare with other languages, I have to use pointers. So in this case, what's changed is that this function takes a pointer to a product. And this product is a pointer to a product, same. So what happens there is that Golang will create actually a pointer. So I have this variable, this banana variable, is a pointer, so it only contains a memory address to an actual product. And then when I increase my stock, when I call this function will receive, same than before, a copy of this variable, but this variable is a pointer, so it will receive a copy of my address, which still points to the same product. So this is how we pass things by reference in Golang. So I quite like this pattern, having things passed by value by default, because we can easily do pure functions. So as a reminder, pure function is kind of a concept coming from functional programming, which is that a function is pure when it has always the same output given one input, and it doesn't have any side effects. So for example, this function takes one product and one name as input and returns one product, but it doesn't have any side effect. So it's a pure function. And so in this example, like I have a red apple, and now I want a green apple, and I'm just saying, well, a green apple is same than a red apple, just it's green. So it's quite a simple example, but this pattern is interesting because here, like it looks like I'm mutating the input product, but actually I received a copy of the product, so I'm only mutating a local variable. So this function doesn't have any side effect on this red apple. And now if I compared my two apples, I have indeed what I expected, a red and a green apple. So red apple didn't become green. And one drawback of this memory model, since everything is statically typed and defined at compile time, is that properties are not optional. I cannot not have this description, for example. Even if here I don't give a specific value for description, my description still exists. And in Golang, there is a concept of zero value. And zero value for a string is an empty string. So in this case, my description still exists, but it's an empty string. And in memory, I have this object. One side effect of this is that, for example, if I have an API and I return an object encoded as JSON, then my apple will still have a description, even though I didn't specify a description. I have an empty string. And I might want to not have a description or have a null description, which is a common pattern in many languages. Yeah, so it's just same thing that I said. And yeah, it's always kind of a problem when we have to deal with other languages or when with nullable properties in a database. For example, if it was a model from my database and my description was null, then my null value is actually becoming an empty string, which is annoying. And to do that, until now, we had two main patterns, which were kind of recommended by the community. The first one was to use Boolean flags. So in this case, I have a description, and I have a Boolean that says whether or not I have a description. And so if I create my apple without anything, this flag will be false. Okay. Sorry. This flag will be false. And the drawback of this is that I have to handle logically in my code this Boolean. It's not like my description is empty. It's that I have a property saying if I actually want a description. And in this case, in my memory, what do I have? I still have my struct with an empty string, and now I have a Boolean saying it's false. So I don't expect, on the logical level, I would say, I don't expect to have a description. But still, I still have my problem, because now my JSON is even worse, because I still have my description, but I also have a property that says that, actually, no, I don't have a description, which is a bit strange in my opinion. And second alternative pattern had been to use nil pointer values. So now my description is a pointer to a string. And what happens if I define an apple which doesn't have a description? Now I have a pointer to nothing, which is called nil. And so I know that I don't have a description because my pointer just doesn't exist. Because the address is 0. One first drawback of this pattern is that it gets a bit messy. If I want to define a description here, I had to first create this description, this banana description, and then take its pointer value to define my object, which we can see there. So now I have a product with description which is yellow, which is a pointer. So in this case, my description can be either nil or be some string, which allows us to have indeed nullable values. But one drawback of this is that we also have the property of a pointer, which is, sorry, my slide is a bit weird. What happened? Whatever. Sorry about this. Yeah, so now pointers are also mutable, which can create some problems. Like, let's say I still have my same product with a description which is a nillable string, and I have my same pattern than before. Then I have a red apple, which is red. Sorry, my slide is weird. Let's take this one. And then I have a green apple, which I define as same thing than a red apple, but it's green. Now the problem with this pattern is that both pointers share the same description. So when I modified my description, I also modified the description of the red apple, and which creates a bug because now my red apple is green, which is unexpected. So that's one drawback of using pointers for nillable values. And also one other very common problem is that at runtime, my code can just crash. So here I'm trying to access a category name. Sorry. So in this example, I have a nillable category, and every category contains a string. And my category is undefined on this one. The problem is that here, it's not obvious when reading this line, but this will actually crash at runtime because this category is a pointer to nothing. It's empty. And also, when we look at just the definition of this object, my category is a pointer to a category, but it's unclear if the intent of the developer was to pass things by reference or to actually have an optional value. And so, like a few years ago now, generics have been introduced to Golang, and which allowed to have a pattern called the monad, the optional monad from functional programming, which I'm going to talk about now. So what does it look like? Now I can use this pattern. So now description is a mo.option, which is defined here, but like it's the package we are using. So now my description, I can define it as an optional string. Same for the category. And I can define my object this way. What happens in memory in this case? My description is an object. So we kind of go back to this previous pattern using Booleans, except that this time we have a kind of readable pattern. And so now I have my description. This is the memory block we have. In the code base, we have just have to write this, but in the memory side, we have this object. So description has its own Boolean saying if we actually have a description or not. Same for the category. And So this pattern doesn't involve any pointers, which is a good point. And how do I access my value? So it gets a bit more verbose, but now I have some helpers, so I can check if my description is present. If it's present, I can get it. Second possible pattern, which is quite common in Golang, using a getter this way. So I check if my category exists, and if it exists, I can just access it. Or I can just use a default value if it doesn't exist. And so this package, the mo.option, implements some interfaces like JSON and SQL. And in this case, if I define a banana with some description and I encode it as JSON, now I have my object, well, like as expected. I don't see the internals of this mo.option package. It's directly my string, the value I want. But if I define now an apple which doesn't have a description, I will automatically get null. So that's one thing which is provided by this package. This also works with databases, which is a good point. Now the drawback of this pattern, because it's always you always have benefits and drawbacks for everything, is that Golang's type inferences using generics are quite lacking, in my opinion. Let's get some examples. So let's say I have an interface which defines what is a product. So I'm not going in detail of the implementation, and I also have an apple, which is an object that implements this interface. And now I want a simple get product. I want it to return an optional product, which is my interface. And in the concrete implementation, I return an apple. Actually, this doesn't work because I'm trying to return this. So from the point of view of Golang, I have a mo.option, an optional apple, and I'm trying to return it as an optional product, which, as for Golang, is not compatible. It's not a compatible type. So that's one of the drawbacks. The second one is similar. If I defined explicitly that I don't want a description, it's not going to work, because this is considered as an option of any, because it doesn't have a type, while description is an option of string. And so the right way to write this is to specify explicitly the type, which gets a bit verbose and not very elegant. So in this case, this is going to work because I'm forcing Golang to understand that this apple is a product, is the product interface. And this is an optional string, but I don't have a string. But I have to specify the string explicitly. And second drawback, it's not chainable. So let's say I have a variable which is an optional product. So it's either a product or null. And I want to access it. Then the way to access it is this chunk of code, which is a bit verbose in my opinion. But so I have to check first if my optional product exists. Then I can get my product. And if the description of my product exists, then I can get my description. So the good side of it is that I cannot forget to check for nullable values. This is all done at compile time, so this will be written directly in my editor. No errors on the runtime, but the code gets a bit verbose and difficult to read. And so as a summary, like as of today, we have 3 ways in Golang to handle optional or nullable values, which is either the pointers. The benefit is that we can chain calling pointers. I can do banana.description or banana.description.name or something. And null values does work in JSON and databases. Drawback is that this is always passed by reference, so I cannot really use the pass by value pattern. I cannot compare the object. So in Golang, unless I have a pointer, I can compare any struct with another struct. This is perfectly valid. And when I see this, it's unclear if the goal of this code is to be nillable or passed by reference. And it's easy to forget about checking nil values. So we have the second pattern, which is the flags, Boolean flag. And like I said before, so we can chain it, we can pass it by value, which is a good point. It's also comparable because I don't have a pointer. But the readability is quite poor. It's easy to forget that I have a Boolean and use a description, or I can end up in a situation where I have a description, but the Boolean says I don't have a description, which makes no sense. And it doesn't work well with JSON and databases. And now we have this new pattern that appeared recently in Golang using this monad, which is more readable, which is passed by value, comparable because it doesn't use any pointer, works well with JSON and databases. It's difficult to forget about checking the null values. Everything is explicit. Drawbacks is that it cannot be chained, and as I said before, the type inferences is kind of annoying. So that's all for the presentation. Does anyone has any question? It was a bit dense, maybe, but any question, something you didn't understand, or it's unclear? Yeah, Steph, please.
Yeah, I just wanted to know if there is, if you plan another Brumback launch for going more in detail about slice and all this.
I could, maybe, if yeah, if many people are interested, I could definitely go down to.
You already have one in audience.
Okay, I'll think about it then. Thanks.
Thanks.
Anything else? Yeah, Alex?
Yes, I have a question. Firstly, thank you for the presentations. It was very clear. I have a question about the monad, about the drawbacks.
Okay.
Do you think there is a drawback about memory storage? Because I think we store more data in the memory when we use a monad.
Yes, it's true. So my object in memory gets bigger. However, for 99% of the use cases, it's not really a problem. So I would say it depends if we really care about very, very low level and detailed optimization or not, but I would say this is probably lighter than any dynamic language, even if we have indeed like a useless string, for example. So I guess depends on the use case.
Mm-hmm. Okay, thanks.
But I guess if you're doing an API, probably it's okay to not care about it. Yeah. Because Golang is very low level, so it's more like on par with the performance of C++, for example.
Mm-hmm.
So quite close to it, I think. Yeah.
Okay. And going back to the last slide,
yeah,
with the three way to handle things, and by default, from your experience, do you go by default with a monad?
Now I do, yes. Before it was more which one of the bad options I have to choose. I guess I usually chose the pointer pattern because this is, well, it's kind of subjective, but it's really worse in my opinion because it's very easy to get things inconsistent. And you can also just use the zero value, but it's not always usable. For example, if you have an integer, then 0 is actually a value. But if you want to have an optional integer, then like the 0 value mindset just doesn't work all the time.
Mm-hmm. Okay. And is it difficult from an existing code base. For example, if you have a lot of pointers and flags already, and you want to migrate to monad, is there like a lot of side effects to take into account, or the migration is still easy to do?
So I did one migration like this. So I guess the only thing to care about, actually, when I did this migration from the pointer pattern to the monad pattern, the only thing I had to change, well, except obviously a bit of syntax in the logic, was checking null values. I discovered plenty of use cases where I forgot to check if this is nil or not, which is one of the advantages of this, like finding unknown bugs.
Mm-hmm.
Because this is done at compile time. We have to check at compile time if this exists or not. But this is done at runtime.
Okay.
So that's the main difference. But otherwise, it worked quite well. I guess for the database level, so the monad is compatible with the standard SQL interface. However, some ORMs like GoRM doesn't use completely this native interface. So it doesn't work well with GoRM, for example. That's one of the problems I had.
Okay, thanks.
Anything else?